Dear students, today's topic is surface finish requirements in engine cylinders. Here, the main agenda of the topic is what is the meaning of surface finish, why it is required in engine cylinders, next, how do we get that surface finish. These are the main three things which we are going to learn today. And based on these three things, next we have to think which machining operation we have to get what surface finish. That is very important thing. First of all, we will discuss what is surface finish. An engineering component may be cast, forged, drawn, welded, stamped, etc. There are so many machining operations out there. Starting from like forming, casting and forging, which we are going to do there. Second one, machining, drilling, milling, lathe, so many operations which we are going to use. And finally, we'll go with like what is the super finish requirements with the help of lapping, brazing, so many operations like welding operations and all. All the surfaces may not have functional requirements and need to be equally finished. Sometimes some components may need surface finishes, like on the surface of the engine cylinder head, maybe surface finish is not required. But in the engine cylinders, ID, internal diameters, we need more surface finish because the piston should have to go inside. It should have to be moved freely. So the surface finish requirement is very important. Some surfaces, owing to their functional requirements, need additional machining that needs to be recorded in drawing. The designers should have to give what is the specific requirements of the surface finish for that particular portion. Because on the engine cylinders ID, surface finish requirement is there, but on the OD it is not required. The designer should have to give specifically where exactly the surface finish is required. If we don't use the surface finish, what will happen? Because the manufacturer will go for his convenient method of manufacturing. He will not select the particular machines for that. So the surface finish requirement, we have to specify it. Now let us discuss some of the drawings which may call for this surface finish. In this drawing, he has given drilling and so many other geometric dimensions and tolerances he has given, but he has not at all specified any surface finish requirements in this one. But if you go to the next drawing, here these are some cylinders, IDs. Here you can see the symbol. This symbol indicates the surface finish requirements. Here it is calling for 3.2 micrometer surface finish. In this ID also it is calling for 3.2 surface finish, 6.3 surface finish in this one. On the surface, on the top of the surface, it is calling for 6.3 because these are all the functionality requirements. Some part may sit inside or it may move freely inside. For that he has given specifically 3.2 surface finish. See on the surface of this also he has given 3.2 surface finish. Now we will discuss what are all the machining operations. What all the machining operations are there and how much surface roughness it will produce. Like from the casting, these are arranged in ascending order: sand casting, permanent mold casting, die casting, high pressure casting, hot rolling, forging, extrusions, flame cutting and sawing. So many different operations are there and how much surface finish that can produce. We can see these are all in micrometers. How much surface finish we can produce from this. Our main topic is related to the engine cylinder, so we will directly link that engine cylinder surface finish. The requirement is 0.025 to 0.4. So this honing operation, it is one of the machining operation which will produce the surface finish of 0.025 to 0.4. Now let us discuss what is honing operations. It is also one of the machining operations, but in this machining operation, instead of directly using the cutting tools, we are going to use some abrasive stones. When these abrasive stones, when they are in contact with the surfaces continuously, it will remove the surface textures like peak and valleys on the surface of. Honing is an abrasive machining process that produces a precision surface on a metal workpiece by scrubbing an abrasive stone against it along a controlled path. Because here sometimes what will happen, instead of exactly coinciding the axis of the honing tool and the center of the cylinder. If it don't coincide, sometimes what will happen? Then it will produce the runout in the surfaces, internal surface. So we have to first adjust it. Otherwise, it will not give the correct diameter. Honing is primarily used to improve the geometric form of a surface, but may also improve the surface texture. What does it mean? In engine cylinders, what will happen? Sometimes we may produce the cylinder dia properly. Means if the dia 20 is given, we can easily produce the dia 20 by drilling also. One is surface finish requirement. Second one, cylindricity, because from the top of the cylinder to the end of the cylinders, it should have to be in the same center axis. If the axis changes, maybe the diameter will also changes. It will produce the runout. Cylinder is not, because it is based on the piston length. When the piston it is moving from top to bottom, means top dead center to bottom dead center, it should not strike. Typical applications, as we discussed, the major application of the honing is internal combustion engines produce the engine cylinders, air bearing spindles, gears. These are some typical applications of these honing operations. We can see the tools which we can produce some smoother surface finishes. See here, this is one of the spindles. This is the spindle which we use for it, which will rotate with respect to the center axis. These are the abrasive stones which are fixed to the end. Here you can see exactly these are fixed in the proper offsetters from the center axis. This one is also another tool which we use it for honing operations. It is based on the diameter of the internal diameter of the cylinders. If the diameter is more, obviously this length will increases. Here you can see one person, he has done some honing operation. After that he is checking with the use of dial bore gauge how much diameter he has got, because initially the hole has to be drilled by drilling machine only. Whatever the size is available, based on the availability, we can drill it. But after that it is bit difficult to smoothen the surface with the help of drilling or some single point cutting tools which may use. Then finally we have to go for this honing operations. If the diameter requirements is 20, initially we have to drill it for 19. After that we have to give 1 mm for this honing operations based on the amount of material which we are going to remove from the surface. I think from this chart we can easily tell which machining operation can produce what surface finish. Even if we say some shaping, if I want a surface finish of 1.6 to 25, if shaping it is usually the surfaces. If you want this surface finish, you can directly go with shaping operations. The drilling, if you want some 1.6 or 20 up to 20 mm, the surface finish, we can directly go with drilling operation. By using this chart, we can easily select which machining operation can produce what surface finish. Thank you.